All right, so moving right along, we're now to the midway point. 5 out of 10. What we've been building towards with this is learning about friction. So we needed to know normal force and understand reactive forces that we could get to here. Now we have all of that hopefully mastered, so we're able to get to this new topic. Now, friction force, F for force, and usually sort of a cursive F for friction. Sometimes it's just the cursive F and not both of them. But this has a special definition and unfortunately an ugly formula, or at least people feel that way about it because part of it's Greek. So the coefficient of friction is a special piece of information that basically tells you like the grip between different surfaces. And that, for whatever reason, is the Greek letter mu. So mu is kind of like a U with like an extra tail in front, spelled MU if you decide to look it up and see how bad my Greek handwriting is. But it's mu multiplied by normal force. It's the amount of force pushing into a surface, presumably from the weight or some other form of contact, gets multiplied by the coefficient, which is typically some decimal number, and turns that force into friction. All right, so good, great. What can we do with this formula? Well, mu is given coefficient of static friction. As I mentioned, it's just some decimal thing. There are no units on there, and that's on purpose. So we have that. We don't have normal force, but we've already seen this one, right? So we learned that normal force in our simplified examples will be equal to the weight of the object. If there's an angle or stacks of things, other kinds of contact, that's not always true, but it'll be true for us. Where we have to be careful, we want to remember that this is kilograms, and kilograms are an example of mass. So we don't know the weight right now, but similar to before, we can take and put these things together because mass can combine with Earth gravity and basically give us Earth newtons. We can find the weight here on Earth. And so all of this will fit together. Once we have this resolved, we can finish the blue formula, which ultimately was our goal. All right, so mass here, 331 kilograms. Assuming we're on Earth when all this is going down, 9.8 meters per second squared. Kilograms and meters per second squared gives us newtons. That's that definition. And according to the handy dandy calculator, looks like 3,243.8. All right, and with that information resolved, now we can go back and figure out what the actual answer is, right? So normal force plugs back here. Mu is a value that we've had the whole time. So now we're ready. All right, so don't have the answer yet, but we should soon. Mu is 0.49, so in that case, it means about half of the normal force turns into friction. That normal force, which we had to calculate, 3243.8, and then now multiplying that together to get the final answer. Rounded two places because it's the end. 1589.46. There we go.